So I welcome you all on day 3rd. Namaskar, Salam, Sat Sri Akal. I thank you all for being enthusiastic for all these 3 days and joining in really good numbers. Thank you very much. I believe the sessions, the sessions on day 1 and day 2 were fruitful for you. You could have learned few basic concepts or something, some advanced concepts, some coding concepts. I know we cannot, teach you everything, and we cannot make you learn everything in 3 days, but our efforts were for hand-holding you, giving you glimpses of the concepts so that you can, feel more enabled, more empowered to, foster the innovation in your school, in your labs. That was the whole idea of this workshop. Also in future, if you want to have some programs or collaborations with us, you can write to us. You have my email ID in my email, which I sent to you for inviting you. So you can always contact us. And with that, I would like to take this program further and formally introduce today's first speaker, Mr. Banjeet Singh. Mr. Baljit Singh is working as scientist at CSIR-CSIO Chandigarh. He is also working as a fellow at CSIO from 2012. His research work focuses on gas sensing properties of tin oxide based nanostructures and the challenges prevailing in this field. He is highly motivated to have research career in sensors and signal processing. His professional goal is to become a leading engineer in the field of process control. Mr. Baljit is a very young, dynamic faculty of CSIR who is joining us today for our very first lecture. And Dr. Baljit wants you all teachers to put your queries in chat box, and he allowed me to interrupt him in between and put your query forth to him so that he can answer in between his lecture. So we will not wait for the end of the lecture to get your queries answered. Please put your queries in chat in between. I will read it for you to Mr. Baljit and he'll answer. And if someone have very specific query that cannot be, typed in the comment box, it's too long, then you can always raise your hand and we'll give you the mic to ask the query to Mr. Baljit. So with that, without taking much of time, I request Dr. Baljit to take over and take us on the learning journey of IoT protocols and cloud computing. Over to you, Mr. Baljit.
Thank you, Dr. Chandra sir. Thank you for these kind words. I hope I'm clearly audible.
Yes, Baljit, we can hear you, but your screen is not visible. I believe your camera is. Yeah. Now we can see.
Hi, good morning to all of you, all the participants and the team from IMTECH. And thank you again for giving me this opportunity. I'm just sharing my presentation. Sir, is my presentation visible?
As of now, we can see your desktop screen, but we cannot see your PPT. Yes, now it's visible.
Thank you. The topic which was given to me is IoT cloud architecture. I have included most of those things, but because for last 2 days, all the participants, I hope, are being very well equipped with the basic understanding of embedded systems, as well as some introduction to IoT also. That is why I am including a bit more things, and I hope in very simple language we will be able to discuss some of the concepts which are being used. We'll start with a little bit of theory and connecting IoT and our these sensing things, all these embedded system things to our real life, like what nature has designed us, and we'll try to get some insight into how we might have over the generations, how we might have reached at this level of technology where we are today. So starting with the very basic concept of cognition, people from biology background or science background understand these things much better than me, but it's just that cognitive loop, all of us living beings, especially humans, we sense any kind of environment around us, even while walking, talking, eating, or something like that. We learn something from that environment, like that, whatever data, whatever our surroundings are. We get some kind of useful insight from the environment around us, and we act accordingly. What is the requirement at this point in time? Let us say a human being is walking, and suddenly there is some kind of hazard happening, whatever might be, any kind of fire or anything like that. So he or she will quickly learn that he has to, they have to run in the opposite direction or something like that, and they will accordingly act. And then based on their action, they will operate certain set of protocols, like what to do for how much time they have to run, and so on and so forth. So in various different kind of situations, and then they will regularly go in this loop. They will again sense the environment. Now, what is the level of danger? Accordingly, they will change their strategy and act accordingly. So if we go to our embedded system world, or we can say our sensing world, it is almost the similar thing. We do all these things, sensing, learning, acting, and operating via some kind of electronic hardware. So sensing is done by various sensors, as many of the previous faculties and learned people might have discussed also. Various temperature, humidity, like I had been working in gas sensors for quite some time now. So these kind of all the sensors which sense something real world. And then learning is done by, you all know that data analysis is being done. The sensor data is being taken, and some kind of script code is being run in our in any microcontroller or processor. Also it can be done, or offline also in our computers it can be done. So learning is done, and more advanced forms are artificial intelligence, machine learning things. People are doing various different, they try to get many different, we can say different informations from the same data by using various complex algorithms. So, and then based on the data and information what we have gathered, and then we will act accordingly. Our system will act accordingly. So action can be done obviously by some kind of actuator. The name itself suggests that it will actually take the action. It will act. So actuators can be like motors, pumps, some kind of 3D, we can say robotic arm, or speakers are also actuators. So then based on all the set, like what all we have to act, and we will have some kind of set protocols, SOPs, standard operating protocols, and we will complete all those operations and then again sense the environment. This will be done actually in like these feedback loop systems work in like very quickly. It is not something very slow. And when people or environment or things means something and something end effector kind of thing, wherein it will be affected. It can be a mobile device, it can be sensor, it can be any any sensing node which we can form. So when these kind of things are introduced, so action is affecting people or environment or things, and then various sensors senses that whether people are affected by that action, how much they are affected, and whether those things, that means our devices, electronic devices, whether they are affected or not. Then we are like including the things part of IoT. IoT full form everybody knows, Internet of Things. So when we include these things, so then the T part of IoT has been now included in this cognitive loop. So now when just as we just discussed, sensors will be sensing, then operation will be done by software with the help of some kind of hardware. So action will be taken by actuators, and HMIs are common for sensors and actuators both, because they are human machine interfaces, so they can act in both the ways. Like they can be used as displays to give some kind of information. HMI are actually nothing but touch screen kind of displays, so we can input our required parameters also, and we can see what is coming on the screen also. So they act both as sensors and actuators. And learning mostly when we are discussing about cloud computing, as my topic is, so learning mostly, because it is very comprises of very complex algorithms. If we have to talk in layman terms, अगर मतलब ये टफ चीजें अगर आपको लगे अभी सोच के, तो ऐसा ज्यादा नहीं है. एल्गोरिदम्स आर सर्टेन सेट ऑफ रूल्स, वो जिनको हमने किसी एक कोडिंग लैंग्वेज में वी कैन राइट देम. सो वो सर्टेन सेट ऑफ रूल्स का ये मतलब है, जैसे हम ह्यूमंस अपनी लाइफ में ऑपरेट करते हैं. अगर नॉर्मली हमें पता है कि इतना टाइम हो गया है, हमें ऑफिस पहुंचना है, अपने स्कूल या कॉलेज पहुंचना है, तो हमें आज थोड़ा सा हमारा बाकी एक काम शायद स्किप करना पड़े अगर हम लेट हो रहे हैं, या अगर हम हमारे पास ज्यादा टाइम है तो हम कोई एक्स्ट्रा पेंडिंग जो काम पड़ा था हमारी लिस्ट में, उसको कंप्लीट करते हुए स्कूल जा सकते हैं. इस तरह का कुछ भी एग्जांपल आप रियल वर्ल्ड में लेते हैं. वैसा ही चीज जब लाइंस ऑफ स्क्रिप्ट में व्हेन वी राइट दोज काइंड ऑफ थिंग्स, उसको हम एल्गोरिदम बोलना शुरू कर देते हैं. सर्टेन वेरी वेल डिफाइंड सेट ऑफ रूल्स व्हेन रिटन टुगेदर आर कॉल्ड algorithms, and written in a specific language, in a specific scripting language, then it is called a code or script or algorithm. So therefore these terms are sometimes interchangeably used also. So they have different meanings and different importances for computational and computer science people, but still in general terms we can use any of these terms. So So just because this is the last slide of this introductory part, that so just to repeat everything, sensors are something which sense temperature, humidity, moisture, wind velocity, air speed, or anything like that. Something in the real world, in our nature, which is being sensed, and the data is being given to any kind of electronic device, which may be microcontroller or something like that. Okay, some processing device gets the data. It is being done by sensor and actuator, which actually works, which do the actual job of output. So, like I discussed, that motors or something like these things are actuators. Okay, so. Now moving further, so this is a reference model in IoT. People and things, as we were discussing, Internet of Things. So people see there is a this layer which manage and control the whole IoT architecture. So it will operate, sense, and act on the environment, and then it has different roles at the different layers. So these are kind of IoT architecture, wherein how this management and control layer, like that means our software, how it will be working at how it will be giving instructions to the all the hardware components at various levels. So doing anything using like different algorithms and all, then sensing the effect of algorithm and acting accordingly is being done in the environment. And then edge and communication edge to put it in very simple words, आपने 2 या 3 दिन में पिछले 2 दिन में Arduino या Raspberry Pi या Nodemc या ऐसी कुछ और माइक्रो कंट्रोलर्स या इन चीजों का नाम सुना होगा. You might have gone through some of the we can say examples also, real world. शायद LED blinking किया हो या कुछ और थोड़ा कुछ control करके देखा हो. Any device to which some kind of sensor can be connected, and that device can take the data from the sensor and further transmit that data, process some small amount of data processing can be done also, very low level, like taking square root, adding the data, doing average of taking the mean of some data, like let us say we are taking temperature for 5 minutes, and then we are not sending the temperature at every 10 seconds. We are taking the average at every 10 second, data at every 10 seconds for 5 minutes, and then we take out the mean and send the average value of the temperature, so that we get more accurate result. These kind of small things a microcontroller can do when working in IoT. And that last device, last edge, as we all know that an edge of a table is the last point in the table. So that is how this word has come to this architecture language, that the last device of the IoT system to which the real world sensors are connected to get the information from the surrounding or nature or environment, whatever we can say, and it can communicate and send that data to somewhere else where it can be made more meaningful and useful. So that device is called edge computing device. And these, as I discussed, these are mostly some kind of microcontroller based systems only. Ready-made systems like Arduino are used generally as edge computing device. Raspberry Pis are also being used. They we may discuss further that how Raspberry Pis are used both as edge computing device and communication device also, because edge computing device only will only has the responsibility to transmit the data to some kind of communication we can say stage, from where it can be sent to cloud or something like that. But Raspberry Pi, because it is Wi-Fi enabled already without using any separate hardware, like on Arduino, if we use any other hardware, you might have heard that these are some kind of shields or Ethernet shield or Ethernet module to be used with Arduino, or Bluetooth shield. All those are separate hardware, so it does not have its inbuilt capabilities as such to communicate that data. But Raspberry Pi being Wi-Fi enabled, it can directly be connected to IP. That means it can directly be connected to internet, and through TCP/IP generally through those layers, the data can be transmitted. So then from edge device, whatever data we are talking about, it comes here, and then that data we have to contextualize. That means make a meaning out of that data, then ingest that data. That means we have to process that, like that means we have to get that data to our database, and make it a part of regular system, and then processing that data gives useful information, and then storing that data so that later on also it can be used to check what happened at what point in time. Okay, and then application and services based on this data, what we have received basically from people and things through this communication links, then we will take some kind of decisions. So this is we can say that okay, the data normal processing is being augmented by some kind of artificial intelligence behavior. So and so, but due to these kind of these layers, so and any kind of data processing will result in some kind of intelligent decision over time. Let us say we sense that okay, pollution is increasing day by day in some part of a city specific. Let us say I am sitting right now in Chandigarh, in our industrial area, due to some over use of any kind of burning processes or something like that, gas pollution is being increasing. So if my gas sensors can check that okay, air quality index in that specific area is going bad day by day, and based on the regular continuous data processing, we can then come to a certain decision that okay, there need to be like this kind of augmented intelligence can bring in hardware and real world and software, we can say, merge together, and it will give some kind of report generation or some kind of output, we can say, display on HMI, that okay, in this specific area the air quality is very poor, so we need to do something, like we need to physically now go and interact with people, something like that. So it may give intelligent information also. The work which generally humans do based on the data and artificial intelligence, it can also be done. So this is all the part of we can say an architecture of IoT communications system as well as data processing system. So see the implementation view of all these same things, people and things we have already discussed most of the things. They are based on software and hardware. Then it consists of world, environment, things, sensor, actuator, everything comes in this layer. And then in next layer, edge and communication link, wireless sensing network, the hardware buses, wired or any other Bluetooth or any other medium can be used. Then bridge, this link is connected through a bridge, edge gateways as we were discussing. Then IP enabled devices. So then cellular method of connection, satellite method, optical fiber or other fiber, copper cable, and all these methods are to communicate. Okay, and then once the data is being communicated and reaches the cloud server, then we have to contextualize that data in terms of, okay, of which region, why the gas, why the pollution data is increasing only in the industrial area part, not in the rest of the Chandigarh. These kind of things, contextualizing from the social aspects. And then as we were discussing, that ingesting that data, keeping that data in various batches and everything, then processing that data, event processing, batch processing, and these are various different algorithm types to process the data. Then we have to store that data in different ways. So time series analysis in our database, SQLs and all. These are various, we can say, database management tools or techniques. Okay, then machine learn, that augmented intelligence, the reporting based on the data, which I was telling that, okay, some kind of output or some kind of analysis will be generated. So based on these analytics and machine learning, and this later on, this data can be used for whenever somebody needs any reference, so the data can be searched and accordingly useful information can be given. So then augmented behavior means based on this data, some other real life services, machine to machine interface or communication, various workflows, like why industries are using these kind of pollutants, and how much time industries are working. These kind of things can be done, and in real life, in real life they can be impacted. Now there are certain quality attributes, but I think we are I'm taking much of the time in this. We may skip this for now. If somebody will be, I don't think it is of high interest to anybody as of now, because this is more of, we can say, when we go into algorithms, then it is required. There are certain design considerations of yes, sir.
I believe we are seeing two slides on the screen, but one you are discussing and the next slide. So can you change the layout so that we can see the main slide only?
Yeah.
In the bigger pictures. I believe layout which you have selected.
One second, sir. Sir, and now what is visible right now?
It's your PPT slides, but not in the presentation mode. For attendees, if you have any questions, please put your questions in chat box or please raise your hands.
Sir, now is it fine?
Yes, it's good now. Yes.
Okay. So, okay. So I think we were on this slide. So now it is somewhat more okay. The theory part we will not discuss more, and the design consideration actually to let us say now coming to doing some kind of basic projects in your school or colleges with your students. So how to start designing any embedded system also in general, but specifically IoT-based systems. So what are the physical signals that need to be measured? We need to be very clear about the application, and then accordingly we need to choose the sensors. How frequently we need to collect signals, and how fast data should be exchanged over the network. So that this also is important because we need to have clear understanding. Okay, as we were discussing temperature thing, let us say you have to control the environment of a single room, your office or your classroom, that air conditioner or something, you need to control yourself automatically, something like that. So the temperature does not temperature of a room does not changes every 10 seconds or so. So it is sensible to take data every 1 minute, even 5 minutes can be some at some instances it can be sufficient. So so that our data transmission requirements should be optimized, not maximized. We should not be sending data every 1 second or 2 seconds. So it may increase the bandwidth requirement and so on. So further we will be discussing MQTT. Why it is being preferred in IoT protocols over HTTP is important. So we will quickly go to that part also. Then should sensors be connected to cloud directly through some kind of Raspberry Pi kind of device, or via a gateway device? A gateway as a name in common English suggests that it is a path through which the data can be sent. So let us say any Arduino device. I have kept one additional protocol to be discussed. It's very important and emerging protocol to be like it is coming in limelight. So we will discuss that also. It is important in this gateway perspective. Let us say Arduino and some sensors are used. From that, you are sending data to a Raspberry Pi device, and there is another Arduino in another corner of the room, or maybe in second room, and you are sending data to Raspberry Pi. So this data is not through cloud and not through internet at all. This is offline communication protocol, maybe through Bluetooth, through Zigbee, and through or through long range radio, LoRa communication, we name it. So this is what I want to discuss also, because it is a radio frequency communication which is for intended to use for long range and for low power. It consumes very low power as compared to the conventional RF radio frequency communication. So, and the hardware is also like many people might have told you that doing work in Arduino or Nodemc is not too much of a difficulty now, because it is cost effective also, very low cost. Similarly, some of the LoRa hardware is nowadays coming in very economically. So you can have those kind of trials also. You can do some projects wherein maybe on one floor all the classrooms or some kind of important data from classroom is being sent to a common Raspberry Pi. And in every classroom there is Arduino, and through LoRa communication you are sending the data to a single Raspberry Pi. Now that single Raspberry Pi will be named as gateway, because that single device will collect the data from all the edge computing devices. Now I think it will be making a bit of more sense that edge devices are which are placed in each and every room, single room. Now each edge device is sending the data to a common central place. This is computer science people call this as topologies also. This is kind of star topology. So and all the devices are being sending data to Raspberry Pi. This Raspberry Pi through TCP/IP layer basically is connected to the cloud. So the cloud is nothing but it is an IP, we can say it is an IP address wherein you can store your data, and that service may be free or charged based on your data requirements or and other commitments. So this particular Raspberry Pi is now gateway to all the data of all these nodes, all these edge devices to the cloud. Okay, so now next thing is how much memory offline. That means in each and every Arduino or something, how much data you have to store, and how much memory generally on the cloud is required, for how many months or years you have to record the data of every 1 minute or 5 minutes of various different sensors. And there are many more design considerations. So hardware design of IoT sensor nodes. IoT sensor nodes, as we were just discussing the Arduino thing, it consists of sensor device, microcontroller, communication interfaces like I was saying Bluetooth or Zigbee or LoRa or something like that. Power management module, that means there might be some battery or there might be some adapter, 5 volt or 12 volt adapter. So those all come under power management module, and some other peripherals based on the requirement. So first step is to evaluate and select of an appropriate sensor. So IoT sensor resolution, we have to decide. This means resolution, all of you are knowing that it determines the smallest measurement that a particular type of sensor can reliably detect. So type of sensor required, so digital or analog sensor, both can be used. So based on our requirement and what kind of sensor is available, we have to decide and choose. So then if you are using analog sensor, then we have to do some kind of signal conditioning. That means we have to convert this analog data to the digital data. So in general, it is called ADC. A common thing which is already there in the Arduino also. 10-bit ADC is there inside Arduino. So it's very commonly used for the analog sensors. When actually you will be using, then you will. I think in the next session you are going to transmit some kind of sensor data over the cloud also. Some kind of account you will create over the cloud. So you will have that demonstration what I am talking about. So these things are basic. I think we will. Okay, I'll quickly go through them. A microcontroller selection is important. Okay, based on number of inputs and outputs and how much memory is there. So we have to decide. Then algorithm, various algorithms are there. Like why algorithm, as we were discussing, you have to write your small codes with the help of various microcontroller has various libraries and various help topics also, so you can use these kind of things. Then if the data is of very critical use, then security encryption things you have to use in IoT. It is very important, but okay, we are not discussing it today. It is introductory part only, but this is very important and hot research topic also in IoT domain. So then power consumption, microcontroller sensors and all the system, we have to optimize the power consumption. Then communication, as I was already discussing. So LoRa, 4G LTE, Cat M1, this NB-IoT is narrow band IoT, some kind of over 4G only, in using very less bandwidth. Specifically for IoT applications, people are giving some bandwidth of their 4G signals. Jio has started giving, I think Airtel also. So we have to like specifically request them for NB-IoT kind of SIM also is available. So, and there are various hardware in which these SIMs can directly be used. So Arduino also provides Arduino, normal Arduino does not have SIM card support, but there are some modules, MKR, NB 1500, something like this name is there. So those are NB-IoT enabled Arduino modules. Then power management. The sensor nodes are designed to last for years, and this depends on the power source of the sensor node. So there are certain kind of CMOS batteries, kind of coin cell batteries are also there. So people have achieved for very small, very small power consuming IoT hardwares, the battery life of over 10 years also with a single coin cell battery, that which in some of the watches and in our computer we use one single cell. With that, up to 10 years of greater than 10 years of lifetime of hardware also is there. So, and this is achieved with by using various sleep, deep sleep, and these kind of algorithms using timers and all to optimize the power consumption. So this all depends on how efficiently we write those lines of code which we call our algorithm. So now this one is some important part, and which I wanted to discuss as I was telling that LoRa, it is short name for long range, is the spread spectrum modulation technique derived from chirp spread spectrum technology. Actually, Semtech is a company who has patented the LoRa protocol and devices. So it is a long-range, low-powered wireless platform that has become now very very common technology for IoT networks worldwide. So quickly going to I'll skip this. I'll just show you one of the IC which we have with us. This is a ready-made module which we get for LoRa communication. So this is the IC which is being used based on that Semtech LoRa platform only, but somebody else might have also devised this thing. So AI Thinker is the company behind this. So as I already discussed, that in one building or in one agricultural field or something like this, wherein up to people claim that up to 10 kilometers also with some high power antennas they have achieved with the LoRa, but practically we have been working on this technology for quite a few time now. So we could only achieve with small basic antennas, we could only achieve 600 to 700 meters of offline communication range, which is even that also solved our purpose, because the Bluetooth ranges are very limited, and also LoRa was taking even lesser power than Bluetooth. And it is just to sensitize you that okay, this can also simply be used, and this the code, the algorithm to activate LoRa, we can say activate or use LoRa, are available on GitHub or any other communities. So very commonly, if we search Google, we find this. So by using 2 or 3 LoRa modules with various sensors and one Arduino in each room, you can automate your complete home yourself. So okay, without using all Wi-Fi, without using Wi-Fi enabled devices in each room. So you can bring down the cost also. Okay. So these are some features of LoRa. We will skip this for now. I have almost discussed all of these. So this is one an additional feature, GPS free low power tracking application. Also people are using LoRa for this thing. So, and it the communication data is end-to-end encrypted with this security protocol. So now coming to the major topic which we had to discuss. Actually, the topics are both HTTP and MQTT, but I am focusing more on MQTT. At the same time, I will be discussing something about HTTP. See, HTTP, we all type HTTP in our whenever we have to type, or it automatically comes whenever we have to open any website. So and websites are mostly like YouTube and other video streaming platforms are data intensive platforms. So wherever bulk data transmission has to be done, if our application requires bulk data to be transmitted at once, like video stream, if that also in 4K or HD, something like that, then HTTP protocol is definitely to be followed. But why MQTT is being used for IoT applications is that, as you have discussed in last 2 days also, embedded systems and IoTs are using various different sensors. In normal environment, we have to sense something, and then we have to send that data. This is the major requirement, and then we have to receive that data somewhere else, and accordingly we have to take some kind of action. So wherever there is crunch of bandwidth, or we can say wherever we are operating in constrained environments, that means maybe agricultural fields are in villages, and maybe in our homes, even till today the 4G networks are not good at the remote locations. We are still getting the edge communication, that means 2G communication till now. So that means that data transmission speeds are very less. So which means that the bandwidth which we are getting is less. At that point, at all these places, so the use case scenarios have increased manifold as compared to HTTP when coming to the real world sensor applications, so IoT applications. then MQTT is being used. Okay, so MQTT was invented by Andy Stanford Clark and Arlen Neiper. So they were both together working on this. So in 1999, initially it was invented, and their use case was to create a protocol for minimal battery loss and minimal bandwidth, connecting oil pipelines over satellite connection. So they had following goals: simple to implement protocol should be there, provide a quality of service data delivery. We will discuss this quality of service, very important attribute of MQTT, which is used. I'll just go to that point. Lightweight and bandwidth efficient, data agnostic, and continuous session awareness. So MQTT stands for Message Queuing Telemetry Transport. It is designed as lightweight messaging protocol, as we were just discussing, and that uses publish subscribe operations. Okay, so so what does this mean is that whenever the data has to go from this end, we can say edge device to cloud. So we say that this device will publish the data. We'll just see the protocol and to exchange. Okay, it uses publish subscribe operations to exchange data between clients and the server. Its small size, low power usage, and minimized data packets and ease of implementation make the protocol ideal for machine to machine or Internet of Things world. So okay, now we will go to see this. This is a client which can be our edge computing device. It publishes. So it publishes to which thing? It is some kind of broker. It is being shown here. Na? So broker is somebody who connects this client, which is publishing, and to the clients that are subscribing to that data. So it is nothing but a communication link, we can say. Broker, which is a server that handles data transmission between the clients. So this publishing and subscription is being done on a name, a topic name. Topic, which is the place a device wants to put or receive a message to from. The message, which it is actually the data which is being sent. Okay, publish is the process a device does to send its message to the broker. Subscribe, where a device does to retrieve a message from the broker. So going somewhat more, okay. First, number of devices connected to MQTT brokers. Actually, it depends on the broker service provider. Really, it is limitless, or we can say millions of devices can be connected to one broker if broker limit is not like reached. So it can reach a massive number of clients. Those are publishing and subscribing all the time. But the amazing part of this isn't only the huge number of these connected devices, but also the fact that any device can get any other device's data at any time. As a result, the application based on these quickly shared data are limitless. So this is the architecture. In general, IoT architecture, we can say these are edge computing devices. We can say node modules. So these all have RF antennas. As we discussed that through these RF antenna over LoRa communication, low power through low power RF communication. That means in our case, I have discussed and used LoRa communication. We send the data to internet enabled gateway. That means some kind of, you can say, a Raspberry Pi device or something like that. It collates all the data from all the devices and then sends over the cloud to it publishes the data through this broker. Okay, so and then this user can subscribe to the data. How? whatever topic it has been publishing. So this user will subscribe to that data, and it will be getting the real-time data. So at this point in time, okay, if I can't show you practically any example, but okay, I'll give you some kind of screenshot if possible in some other presentation if it would be there. So MQTT quality of service. This is one last thing which we need to discuss. It's very important thing. Quality of service is a attribute of MQTT, is a property of MQTT which can be customized according to our need for reliable messaging. So these are of three types: QoS 0, 1, and 2. So quality of service 0 means the data. It is like we can say fire and forget mode. That means this client which is publishing the data will publish it once and then forget it. It will not publish it again, whether the broker efficiently receives it and the end user subscribes to it or not. So it does not survive failures, and the data can never be duplicated. So QoS is at most once. It can only publish the data once. Okay, it only publishes, fires, and forgets. So QoS 1 is at least once. It will publish, and this is PU back. That means publishing. It will get acknowledged signal of publish, and until the time it does not get this acknowledged signal, it will again publish. If we select QoS 1, it will again publish. So survives connection losses, but the data can be duplicated, because if connection is lost, okay, it publishes again and again, again and again. Let us say the internet connection becomes stable again, internet comes back. So it may publish 2 times before it receives. At least once the data will be going to broker. Now, the most secure and reliable method is QoS2, but we do not use QoS2 always as it is time consuming. So, it gives initially it first publishes the data, then it gets the first acknowledgement, and then it will give the data like that. That means it will start the communication and it will get the acknowledgement, okay, that communication is okay. Then it will publish the data, and then it will get another acknowledgement of publish complete. So survives connection loss. And
Baljit,
the
sorry, I mean, thank you, but we are running short of time. Please, complete your in like 5 minutes. Yeah.
Yeah, just one last example, and I'll finish. So as we were discussing, quality of service 2 will survive the connection losses also, and will exactly publish the data only once. So these are kind of just example. These are the topics. That means anything like this you can write in your program line, and any client can subscribe to the topics, and it will get the data, or you can say it will get the status of specific topic, what is happening, what is published right now. So messages can be text, images, or anything else also. So in any specific format we can send the message. So see this device side MQTT client, it will publish the event, and any IoT server, this MQTT broker can be one of the example is this. Another Mosquito broker, Hive, MQ, many names are there. I think in next session we will be doing all those. So, and then application side, the devices will be, client will be subscribing to the data, and on real time it will be receiving the data, and it can do whatever they actually want with this IoT data which they are receiving. So I thank you all of you for patient listening, and I know that even I am feeling I had kept more things than required in this much time, and I was myself fumbling to go through all the things to somehow complete, and it's not a good practice. I'll from next time keep the uh, check of time also. So my apologies and thank you. Thank you all. And any questions?
Thank you, Baljit. It's not about regretting of something when you are delivering information to the participants. So it's really nice to hear from you at the length, and you tried your best to give the most out of your lecture. It was really informative. Even I glued to my screen for the whole time, and kept on learning how Mqtt and the protocol works in IoT. Thank you very much. I believe since there is no question, because I believe teachers are more now interested in listening to something prototyping and other thing. So it's okay. Yeah. It was really informative, and thank you, Baljit, for joining us at a very short notice. Thank you very much. Since we are running short of time, I would just introduce our next speaker, Dr. Bhalla, who is with me. You all can see him on your screens. Dr. Bhalla is the principal scientist at CSIR-IMTECH. His area of interest is biosensors and rapid diagnostics. And Dr. Bhalla has done his MSc from PGI-MER Chandigarh, PhD from CSIR-CSIO Chandigarh. He has done his postdocs from Europe and Canada. From Europe, he did his postdoc from Bologna University, Italy, and in Canada from Montreal University. Dr. Bhalla has published more than 40 papers, and he's editor of Bio Nanoscience Journal. Dr. Bhalla has developed kits for explosive detections. He has developed another kit for water testing. He has developed a rapid test kit for detection of heart attack based on detection of biomarkers. With that introduction, I am handing over the stage to Dr. Bhalla for his talk. In the meanwhile, I'll be sharing his PPT with you all.
Can you listen to me? Good morning to you all. The topic of the topic of my presentation is basically this sensing of biomolecules and application of biosensors in healthcare. So what I'm going to explain to you is that is slightly different from what you have been learning, which is mainly on this Arduino-based programming and other things. What you see in the center is basically a chip, So this chip is the one thing which is the electronic is the transducer, which helps in the detection of the biomolecules. The biomolecules is a major interest area because a lot of these molecules, they appear in the blood, and they can they can they can be very useful for diagnosing the different diseases. So biomolecule is one of the interest area, but the same way another molecules, a lot of molecules one would be interested in to detect environmental molecules, contaminants, pollutants. So so this is what you see in the center is basically a chip. It has a drain source electrode, and on the center of the chip there is some kind of a nanomaterial. And what happens is that what you see is that from the sample the target molecule, it comes and bind on the sensor, and on the sensor we have this kind of a biomolecule which is called an antibody. You all are basically familiar with what is an antibody. So antibody is something which can actually be used to detect a biomolecule or an environmental molecule. It can be, it is a very lock and key kind of a arrangement. So this molecule, as you see here, that the other molecule, the green one, it just passes through and it's not binding to the antibody molecule, but the one which is very specific molecule, it's just goes and bind, and there is a generation of a current signal. What you see in the in the insect, there is increase in current with time that gives. So that is how the mainly the sensors operate on, but so this is basically what we have in IMTECH is a biosensors and nanotechnology lab. So biosensors and nanotechnology, they have like they have something kind of a handshaking arrangement, because the biosensors, for the biosensors you need these nanomaterials as well. So nanomaterials, why we call it a biosensor is that the recognition is made feasible by a molecule which is let's say an antibody molecule and an enzyme molecule. So this has its origin from the biology. So we use the biological recognition molecules because they are very specific. They're very lock and key specific molecule. They have very good specificity. They will not let's say they will not allow any other. They will allow only the specific molecule to bind. So herein you see an antibody which is pink colored, and the green color is the target. So the antibodies, they are very specific. The enzymes are very specific. So that's why the biosensors for what you have been seeing all these days, for those things like the specificity is not the specificity is not required, but for the detection of the clinical biomarkers, the environmental biomarkers, and in certain cases the specificity is a big concern. So let's say if you want to just monitor your pulse and you want to use some kind of a sensor to monitor the heart rate, in that case it's possible for some to design an electronic sensor, but to detect a biomarker in the blood, in that case the specificity is a major concern. So that's why this lock and key arrangement, which is offered by the enzymes, the antibodies, and other biorecognition molecules, that concept is used for the biosensors. So so what you see over here is some kind of a screen printed electrode, the blue one, and down there is some kind of a chips. The screen printed electrodes is the one electrode which is frequently used in your homes when you do the glucose sensing. In that case, this kind of a screen printed electrodes, they are used, the blue one. So we insert the electrode, we put on the black dot, we put our blood sample, and then the glucose concentration is measured. So that is a simple example of a biosensor. In that case, an enzyme is used, glucose oxidase in the sensor which we have frequently be used in our homes for those wherein so some of our parents or some of us, maybe they are diabetic and they use these sensors in their homes for home monitoring. So and these most of the sensors are one-time use. So you just use it to put the blood sample on them, and then these are basically, then you have to discard it. So what do you see? Some kind of a nanomaterial here, the graphene. The graphene is what, when you write with your pencil, the lead pencil on the paper, what comes on the paper is a multiple layers of graphene basically. So the lead pencil is having graphite, but when we write, so graphene is having very good electrical properties, and that can help us in they are frequently used in sensors. These molecules, they are frequently used for sensors to basically enhance the sensitivity. So they are very good at. So one thing is that you can whenever you want, you can write your questions, and we can address as such if there is a curiosity, instead of just lingering on throughout the presentation. So I'll be happy to answer the questions whenever they appear in your mind. So graphene is basically graphene is the one molecule which is frequently used for to get a very good electrical signal. So in that blue sensors, what you see on the screen, Banjeet electrode, one can immobilize put the graphene, broadcast the graphene, and then the sensitivity of the sensors. Like say, if you have the sensitivity 1 nanogram per ml, then it will be pushed to 0.1 nanogram. So better sensitivity can be achieved because these are very good electrical conductors. So they can help improve the surface of the electrodes. So CNT is another. It's just graphene which is rolled up. So you have a paper and you just roll this paper, and that makes a carbon nanotube. That makes a carbon nanotube. So it's rolled up graphene that's called CNT. So this material is again used. This material is again used on the electrodes, carbon nanotubes. So they are used in for electrical these biosensors as well, but they are used for other applications as well. So same way you can make the semiconductor quantum rods, which are just fluorescent molecules. So it's possible to use to make these in the lab. Using some simple techniques, it's possible to use this elements, cadmium telluride, and to have the fluorescence things. We can make it in the lab. So what I'm going to explain to you is basically what biosensors is. By the end of the talk, you will be able to appreciate what biosensors is, how sensing takes place, how to make a label-free detection of analytes. Label-free detection means that just the same way what I showed you in the first slide, that there is just the target is coming and detection takes place. So that's what is the label-free sensing. So the role of nanomaterials, all these nanomaterials, what I showed you, this graphene, carbon nanotubes, these are what are the nanomaterials. So what is basically a biosensor? So you can appreciate, you all know about the dogs. These dogs are frequently used in the airports to detect the explosives. So this is the dog's nose is a very great example of a natural biosensor. So in order to create a biosensor in the lab, the scientists, they take the encouragement from the dog only. So this capillary, what you see, is basically created by MIT professor. That's technology is called FIDO, and we have also been working in IMTECH on explosives together with CSIO for a national mission project. And the main technology which was already existing, but is this capillary-based technology, which is in equipment is called FIDO, developed by an MIT professor. So this is inspired by a dog nose. So the antibodies or the biological receptor molecules in the dog, there are some receptors which detect the presence of explosives. And in this case, some antibody layers, some biorecognition elements, they are just immobilized in the capillary. And when the explosive in the presence of explosive, so there is a negative pressure pump in this capillary which sucks the air inside. And if the explosives are present in the air, then there is just a fluorescent polymer is used inside this capillary along with this bioreceptor layer. So that fluorescent polymer is also immobilized, and if the explosives is present, then there is a signal. So this kind of a sensor is basically inspired by dog's nose. So a biosensor, to give you just to give you a definition, is basically an analytical device which is used to determine the presence and the concentration of a specific substance in a biological analyte. That is a biological analyte. So there is at the heart of the biosensor is basically a bioreceptor layer. And then there is a transducer which converts the recognition event there is a recognition event. So the bioreceptor, when it comes and engages with the target, then this transducer, there are different examples of transducer, and I'll explain to you what this transducer is. And this transducer converts the biological recognition event into some kind of a signal. So the signal might can be an electrical signal, it can be a fluorescent signal, it can be different signals, can be type of signals can be generated. There are a number of examples are now present. So let us just understand for the time being that the transducer converts some kind of a recognition event at the sensor surface into some kind of electrical signal. And there is then some kind of a signal processing that generates and some display which tells you, okay, the concentration of the analyte. The same way what happens in the glucose sensor, which you might be using in your homes, or you might have used. Somebody in a hospital might have pricked your finger and then put the blood drop onto a glucose sensor, and then you get some kind of a concentration for the glucose. There is a display, and inside there is some program which. So that bioreceptor can be a enzyme, as I said to you, an antibody, an aptamer. So aptamer is basically chemical moiety that's just generated in the lab, or there can be some other kind of a receptors can be there which can be used to there can be another examples of receptors which can be used to detect the target molecules. So in order to realize diagnostic, we need to have something that serves as a recognition element, and it's the heart of the biosensing device. So by now, I hope you have you have appreciated that there is a sample, and it comes in contact with the bioreceptor layer. Then there is a transducer which converts this recognition event into some kind of electrical signal, and then this signal is processed and there is a display. This is a screen-printed electrode is a classical example of a transducer. So this screen-printed electrode can be developed by the same technology which is used for printing your cards. As we know that a screen is used to print on the cards, and the basic bottom of this electrode is something like cardboard or a plastic transparency sheet. And on that, these electrodes are printed. These electrodes are mainly printed with inks, which are conductive inks. So on the center of this, what you see, this is basically the design is inspired by. So there is a walking electrode at the center. What you see in the circular one, there's a counter electrode and there is a reference electrode. So the working electrode is where the signal, the main reaction occurs. The recognition event occurs. The counter is just to get the current, and the reference is what gives you the reference. So this is the same. You have heard of SHE, which is standard hydrogen electrode, which is at zero potential, and then reference electrode AG, silver chloride, calomel electrode. So silver chloride reference electrode is very easy to print, and that is used as a reference, so that we are able to know. This reference electrode let us know. It allows us to know where we stand. So without this reference electrode, it's very difficult to make out what is exactly the make out the potential. And then at the bottom, what you see is are the connections to these three electrodes. So all these these connections is where we are able to connect it with the wires to a detector, or maybe there are some SMD connectors which are already in the detection system. So we just plug in this electrode, and we are able to put the drop of blood in the center, and then this reaction occurs on the central electrode, the working electrode, and so what kind of reaction occurs? That also, like I'll show you some examples, like. But the basic reaction could be an enzyme-based reaction. So the enzyme is immobilized at the central electrode, or an antibody-based antibody is immobilized in the central electrode, and then when the target comes in bind, then the signal is produced, which is an electrical signal in this case of transducers. So this is experimental laboratory setup. What you see is basically this one wherein the CSIR logo is printed is basically electronics which is designed to detect the electrical signal, and here the casing, the plastic casing, which is basically for a fluid management, and inside this plastic casing we have the electrodes, and these are connected by the wires which go into this detector, the electronic detector, and there is a peristaltic pump also which is there. You see the red spot. So this is for the fluid, pushing the fluid towards the electrode, and then this is the discard. What you see is the beaker. This is a classical setup to pin the signal, and on the computer what you see is the current signal. So x-axis is basically a potential, and on the y-axis you have the current signal. So whenever this reaction takes place, there is some production of some kind of a current, what you have to remember, and the current is basically proportional to the concentration of the analyte. So more the concentration of the analyte, the more is the production of current. So the classical example is the glucose sensor. So the enzyme glucose oxidase, it's immobilized on the glucose oxidase enzyme is immobilized on the electrode, and then more glucose in the blood, the more is the production of the current, and that current can be detected by this electrical device, what you see, and then with the software it's possible to generate know what kind of a current is there when we are scanning with the potential. But the potential in the commercial devices, it's just kept fixed. They just know at what potential, that's a static potential, and they just know that at what potential this current is going to appear, and they just measure the current. But in the lab scale, we are just doing the potentiometry. So we are doing a potential scanning, and we are able to get this bell-shaped curve. So which is at different point. We are doing a potential scanning, and there is a peak at one potential, and at the other potential you have lesser currents. We do this scanning kind of a thing, but in the actual devices, we are able to make out that okay, what is the from here we are able to make out like what is the exact potential. So and then it's not possible, it's not important to do the potential scanning. It's possible to just in the actual devices what are used in the homes, one is able to provide a static potential and then measure the current. So more the concentration of the analyte, the more the current produced, and we are able to detect the analyte. This is just you can actually make these electrodes from scratch. It's actually possible to make these electrodes from scratch. So this is one example. So in this case, on a transparency sheet, we have demarcated the electrodes with a laser cutter. We have made these experiments were performed in IMTECH only. So we have demarcated using a laser cutter. The electrodes, and these electrodes can be so we put an adhesive tape, the brown one, which has a circular cutout in the center. So when we put this sticker layout on the electrode, so a well is created. The well is able to do the fluid management. So on the on the well, one is able to put the on the well, one is able to put the sample in the center of the well. So other sides are protected, and in the center cutout, one is able to add the sample, the liquid sample, and then there is connectors are also there. So where the layout is not the layout, this adhesive overlay is just to protect the wires from the liquid. So that there is no short circuit. So this is just how it is possible actually to create a sensor in the lab, a low cost sensor. But the most successful sensors, they're basically screen printed kind of electrode. What you see also in your homes when we do the glucose testing. So in this case, basically a thin layer of metal, in this case gold, is basically sputter coated on a transparency sheet, and then basically this sputter coated on a transparency sheet. These things can be also purchased from commercially from the company. This is how you can create a simple setup to demonstrate to the students. So basically this can be commercially procured. This metal coating on a transparency sheet. These are available with vendors, and then with some kind of a laser, here in this case laser cutting. So laser cutting can be like the electrodes, the 3 electrodes what I showed you. One is the working, another is the counter, and the third is the reference. So we need basically three electrode setup is what we need. So what exactly happens on the sensor is what I want to show you. So the sensor is either having the enzyme present on the circular cutout what you see in the center. Either you have to immobilize the enzyme. Let's say for the glucose sensing, the enzyme is required for some kind of analytes. Let's say this is the example of a pesticide. In this case, an antibody is used to one can drop cast the antibody on the center. So for the production of current, there is another reporter antibody. There is another reporter which has the enzyme. So that generates with the reaction, the chemical reaction that generates a electrochemically active product. That's the naphthol. And once we do the scanning, this naphthol, which is the electrochemically active molecule, that can be detected. So it's an indirect way of detecting. It's an indirect way of detecting. So we use an enzyme reporter here, and that enzyme reporter is basically attached to the. That enzyme reporter is basically attached to the antibody, and so there is a generation of the current is generated by the so either in the glucose oxidase. It's there is not to have this kind of a messy configuration, because glucose oxidase, once it comes in contact with the glucose, it automatically produces the current. So in this case, certain cases where there is no enzyme which is able to detect the molecule, in that case we have to use the antibodies, and in that case we also need an enzyme which is used as a reporter to which will generate a substrate and product reaction, and the product is electrochemically active and that is detected. So it's an indirect way of sensing. So in certain cases, the enzyme itself, like let's say in the pesticide sensing, some people use OPH enzyme, which uses the pesticide as a substrate. In the glucose oxidase, for the glucose, we in our home biosensors, what we use, the glucose oxidase, which is naturally uses the glucose as a substrate, it can be used. But here in the antibodies and an indirect way. So the reaction of antigen and antibody, so the reaction of a target with the receptor coating, and then for the generation of the signal, we use a reporter molecule, which in this case is an enzyme. So it converts one electrochemically active, non-electrochemically active substrate into electrochemically active substrate, and electrochemically active product which is generated is then detected using the potential sweep scanning. This is another type of a very interesting type of a transducer. This is called the micro cantilever. It's a hanging board. So electrode is one kind of a transducer which can convert the signal into some kind of a electrical some current can be generated. Electrode is one kind of a transducer. So this micro cantilever is again one kind of a transducer, very complicated transducer. In the sense that it has to be microfabricated. It's a small micron level cantilever. So cantilever is like basically a hanging beam. It's kind of a hanging beam on which the Olympic swimmers they jump from. But in this case, so I just want to tell you that different research groups, different scientists all over the world, they basically think over the problem and they come up with different kind of a transducers. So what electrode is basically a standard thing. But people also come up with they also use different kind of. So microcantilever is one kind of another like some people they use this microcantilever as a transducing signal. So let us I want to show you from the basic. So this is the microcantilever, which is a hanging beam. So, but this is in micron level. So just like the hair, you say in the air, that kind of a thing. So it has it on the neck. There is a piezoelectric material which is doped on the cantilever. So there's a gold coating. What is done? So this is on the gold coating. What you see, this is the protein layer to stabilize the gold coating, and then on top of it, there are some antibodies which are coming and binding. And so antibody is basically a receptor layer which is going to detect the target. So in this case, the target is basically a TB antigen, but it can be any other target. Can be coming from the blood sample, coming from the air, coming from the water sample, and then with the bridge circuit we can detect. So with the bridge circuit and it display, one is able to. So this is another kind of a kind of a transducer, and people use other types of transducer also, like piezo crystals are they're also used as transducers. So piezo is another example. So one example is basically an electrode, which is very common. But this microcantilever kind of example, these are very sensitive, but they also have some issues because it has to be microfabricated in a fabrication facility. So microcantilever can also give you very sensitive kind of a detection. In this case, there is just in the neck of the cantilever, you have this doped material, and you have to just have the conductivity of the doped material, which changes when you have the stress build up on the cantilever because of the binding event. So one is the basic signal, and another signal is when you have the molecular binding. So these kind of things also. So basically what I have told you up till now. So biosensors, they basically have at the heart of is a biological recognition element, which is an enzyme or which is an antibody. Antibody you guys are already familiar of because of the COVID pandemic. So antibodies, they can detect the target very specifically. So the this is a lock-in key event. So there could be n number of targets, like there could be n number of molecules which are coming in your bloodstream. You want to detect them. Some are cancer markers, some are telling your health situation. So different for every marker, you have to generate a specific receptor, which is an antibody. Just the way the body generates the antibody is the COVID when you take the COVID vaccine. So so enzyme is another. Enzymes can also be used for some. Let's say if you want to the analyte, what you want to detect. Let's say if you want to detect glucose, the enzyme is already available. But in other cases, enzyme may not be like that molecule, that target may not be processed by an enzyme, and that in that case you will have to use an antibody kind of a thing. So in the antibody kind of a thing, like I already explained to you, and the parametric direct detection is not possible. So either you have some kind of a microcantilever kind of a thing, or you can use it's possible to use an electrode as well. But if you use the electrode, then you have to correlate the binding event reaction with some kind of a reporter enzyme reaction, which will bring the signal to you. Coming back to like how exactly.
Okay, there is a question for Dr. Bhalla. Sir, is it possible to develop a portable biosensor to identify contamination of water?
Yeah, so it's possible to do a biosensor for the. I'll give you the example for the water contamination. I'll give you some examples today for the water contamination. My lab has done it. So what kind of a contamination is that?
It's not mentioned. The question is very much broad. So another question is, sir, is there a ready-made biomedical sensors available in the market? Another question is it possible to print these on normal FR4 PCB material? These are 3-4 questions.
So the biosensors are available. I told you, like you can show to your students like the biosensor, glucose biosensor, which is used. You can bring it from the market. Another biosensor I'll show you is the pregnancy card, which is used by women to know. They put the urine droplet on that kind of. I'll also show you the principles. You can educate your students on that. But certain things are very complicated. But in order to understand the curiosity, basically what I want to tell you is that how these biosensors, which are becoming very common. They are entering into each homes so that you're able to understand what is the basic thing behind that those things like. For the water contamination, definitely I'll give you the example, and for the and that kind of a thing can be done in a school level also. And for the other thing like of ready-made biosensor, glucose biosensor, you can actually buy a glucose biosensor. I'll encourage you to go to a shop. It cost at Amazon. It cost around 800 to 1,000 rupees. This biosensor, actually you can buy it, and that will also help you in knowing your own blood sugar. You can monitor and you can improve your health. So these biosensors are inevitable. Like even now ECG machines are coming, which you can buy from the Amazon, and the companies are thinking to put the ECG machine implantable, so it will be located very close to your heart, and whenever there is a problem, immediately one can know. So those kind of things are futuristic, but they are coming in the future. So those implantables will be able to implant the ECG sensor. Uh, um, Once we know that we are going to have some problem, we are more prone. So these biosensors are very inevitable. Like most of the time, we use these bands, these wristbands, and my previous speakers, they might have already told you. So we'll definitely like to know what is our health, how our pulse is changing, and why just pulse and just other our wake sleep cycles and just small things, but we'll like to know so many things about ourselves. And those, the two examples which have just integrated very well into the society is, one is the pregnancy card, which all women they are using to know the pregnancy, and also I'll explain you what is operating in that pregnancy card. And the other classical example, which I'm sure that you are using, is the glucose sensor. But the things are not limited to here. Like we are wanting to create these kind of biosensors for a number of things. So again, like the basic curiosity question, which is basically how to do the detection. So as you know that the antibodies, they are able to detect the antigen very specifically, but how to exactly do the detection? So micro cantilever, I already explained to you. QCM is basically piezo based. So there's a change in weight when when the antigen antibody event takes place. So there are so all these examples, they're very bulky. SPR is another example. So right now, what people are thinking, what scientists are thinking, is basically some kind of a physics changing at the surface. So when this antigen comes and bind, you see in the snap in the insert that this one kind of a sensor. So the molecule is coming from the sample, and one molecule goes and bind on the sensor, another molecule doesn't go and bind. So some kind of a physics changing at the surface. The antigen is bringing some kind of a charge, some kind of so some physics changing at the surface that should be able to detect. So these sensors, they're very small. Many of these sensors, what scientists are creating, they are in the nano domain. So these nanowires and nano interdigits you might have heard of, and nanotechnology you might have heard of. So one question your student might ask you is that why we want to make things need to make things so small. So he's already understanding and appreciating the student that why you need to make a computer processor so small. But why will might ask you that why you need to make these sensors so small? Why you need to create these sensors in nanowires, nano interdigits? So nanowires, nano interdigits are sensors you might be hearing that scientists created in the Singapore, in India also, like people are using this nanowire. So why do you want to create these sensors so small? Why do you want to create these nanowires, nano interdigit? So there is an example. This simulation, like many of the people, theoretical physicists, they created this simulation, what is now being commonly called as the gapless width rule. So this gapless width rule, like if you make these things really small, that helps in the sensitivity. So 95% of the current passes below the distance that equals the pitch and width of the electrode. So most of the currents are developing it, and these biomolecules, they are very small, like antibodies 15 nanometer thing. And these target molecules, they are also very small. So most of these interactions, they're building up, in the biological interactions, they're building up at a very small nano level. So in order to, if you make the electrodes so small, Having a pitch in the same dimension can maximize the sensitivity. So a lot of theoretical physicists people, they've done different simulations. So if we make these things electrodes very small, it's possible to push the sensitivity. So this is what has come to be known as a gapless Vogt rule. So this answers why. So what we used to do in the lab is we used to create the structures at 200 nanometer level, 150 nanometer level, 100 nanometer level, 50 nanometer level. So when we push it so small, it pushes the sensitivity. Just like if you make the transistor so small, you are able to push the limits of the processing power of your computer. The same way, if you push if you make the structure so small, it's possible to push. Okay. And so let me tell you all, I was talking about some physics changing at the surface. So this is like how we can exactly, the basic thing is to realize a kind of a capacitor. This can be work as a sensing principle. This is the electrode. What you see, the yellow one, so electrode has got electrons. So whenever there's electrons, the positive charges, that's a sodium ion that comes and sits on the surface. So when we build the primary layer, some layer we deposit on the electrode, the solutions ions they're pushed away in the sodium ions. Basically, they're pushed away in the solution. So there is basically change in the D value, capacitance area upon D. So there is a change in the D value, and also the charges are building up. So this is how the sensing principle, one of the sensing principle I'm demonstrating to you. This kind of sensing principle we are using in the lab. So the antibodies come, they sodium ions, they pushed Hamel's plane of ions, this pushed further away in the solution. And when the antigen comes, this so the ion charge displacement that might be this is what I was telling you about the physics changing at the surface that can provide you a sensing principle. So this kind of capacitance is, so this is the same thing what you use when you're able to touch the mobile phone. This same principle is operating because there is a buildup of charges on you have something on the finger and then you touch the screen. The same thing can be used as a sensing principle. This is what I'm showing to you. So Shekhar is pushing me to conclude my presentation, and I'm ready to show you some more examples. This is the fact sensing. So these nano electrodes, they're printed and when we put this drop of solution. So again, these materials, they've got a huge role, but I promise you to show you. Yeah, so this is the glucose sensor is on the right panel. What you guys are using in your homes, and the bottom is an example of a pregnancy card. So on that, some line develops. So that line is basically using a nano particle that is called the nanogold. It's a gold nanoparticle. That line appears because of the gold nanoparticle. So let us see how this line appears. So gold is actually what you wear the bangle is basically yellow in color, but the properties of this nanomaterial, even the color that changes when the size changes. So if you build a nano gold, that's 1 nanometer gold, it's blue in color, low reactivity. If you make it 3 nanometer, it is reddish in color, and that nano gold is actually used in the pregnancy strip. So I'll show you the example how it happens. It's catalytic in nature, and it also has that property that it's possible to see that with the naked eye, and that's why this nano gold is used in the pregnancy strip. That's again one kind of a biosensor. So this is how it happens. So this is how it happens. You are able to label the nanogold then with an antibody. So when what happens when there is a layer of antibody which is immobilized on the sensor, this layer of on the sensor. So this is what happens when the sample comes. This nanogold sample is the yellow one. Target is the yellow one. So when this comes target identification takes place, this nanogold it appears. And if the target event doesn't happen, that is what you see on the pregnancy card, the red line. And if it doesn't, and the interaction doesn't happen, then the things are pushed in towards the absorbent pad. In that case, the red line to downstream. So the red line appears only if there is an interaction, and they're using this nanogold, the gold nanoparticle, and they're using these antibodies to capture the target molecule, which is a hormone. So this has for this biosensor kind of a thing, you need bioreceptors, you need biology, you need chemistry, you need signal, and some Arduino devices are created by us. to detect the signal, and this nanomaterial is required. So it's a basically interaction between different sciences. So these are basically the criteria we have to consider, and we want to create simple things to complex problems. So at the user end, it just has to be addition of sample. So we don't want to bother him too much. We just want that just addition of sample, and these are the considerations what we have to take. Like we have that thing has to be rapid, has to be specific, sensitive, like it should be able to detect very low concentration of the target analyte, cost effective, point of it. These are the basic thumb rules when we try to create a biosensor. So we want the entire lab, the bulky lab. When you go in for clinical testing, you might have seen the crores of investment rupees. And we just want the goal is basically to create these tests in a simple level, so that at the patient level, at the user level, we are able to detect different molecules and analytes which are of interest. So the glucose is biosensor is a classical example which we use in our homes, and that is able to detect the glucose concentration in our blood. So we are able to manage our diabetics. So the same way, people suffering from different diseases, they might be people need different kind of devices. So somebody asked about the contamination in the water. That I think can also be so by this change in color. So what we do in the lab, we try to create these kind of things. So there should be some change in color. So that can be detected by a mobile detector or an Arduino device. So for the water contamination, we create this again the nanoparticle based things. I don't want to enter into the deep details, but then we created this Arduino device on the right side, which can detect the change in color. So what we do is that basically, if the contamination is present, there is a red color appearing in the solution. So the red color means alarm. And the intensity of the red color is detected with the Arduino device, and that tells you like, okay, how much contamination is present. So in this case, we are detecting the microbial contamination, pathogen contamination in the water and the food. So that kind of things. So the core reaction is that's basically a nanoparticle based reaction, a chemical reaction that occurs, and that leads to some kind of a color change that is detected by the Arduino device. Okay, so thank you to all, and I'm open to questions. Shekhar.
Yes, thank you, Dr. Bhalla. If there are any question, attendees may raise their hand, so we'll ask, we'll provide the mic available facility. Oh, yeah, there are some questions. Rekha Chakrapani, please unmute to put forward your question. And followed by Joyous Sebastian. And in the meanwhile, there was a question on yeah, please go ahead with your question. Hello, Rekha Chakrapani, please put forward your question. Yeah, so another question was the question which we asked earlier, how to detect the contamination water. So the question now made specific. So basically for chemical, microbial or physical contamination, like the water has bacteria or the arsenic, are there any solutions available for these type of detection kit?
So for the pathogen contamination, the solutions are available, and you can go in Amazon and buy. There is some kits are available, but they're very expensive. So it's costing like 2,500 like that, but they're culture-based tests. It takes a lot of time, 48 hours. So what we created in IMTECH, we patented that technology. It's a 5-10 minutes test, and it gives you a color-based readout, which can be even be read by Arduino device, or it's possible to read with a naked eye also. So those tests are available, but they're coming from the Western world. They're coming from foreign companies, but they are very expensive. For same way, I don't know for arsenic, but I can tell you about the pathogen. Some tests are available in the Amazon.
Okay. With that, Joyous, if you are around, you can unmute yourself and put your query forward. And
Yes, sir. Yes, sir. Good morning, sir. Sir, as the continuation of the same question, detecting pathogens in water, sir. So we need some electrodes for that, or what exactly we need to connect to the Arduino in the color detection?
So basically, there is a color readout. So there is a reagent. There is a reagent, and that reagent, let's say it's a if there is a bacterial contamination present, how the reagent is set that if there is a pathogen present in the sample. So I have got a dry reagent or a paper strip, and if there is no contamination once you put the sample, the water.
Okay.
There is no contamination, then there is no color. But if if there is a presence of bug, the bug is present, then the reaction is set in a manner which is in fact a published report in Camcom by my group. In that case, there is appearance of a red color, and that red color actually the intensity. Then you will also the Arduino device actually helps me in reading the intensity of the color. So sometimes if the intensity is low, then it's not possible to know how much bacteria are present. So for the exactly knowing there is a color sensor in that in Arduino device, and that helps me knowing how much bacteria are present. So it just works in the same way as a spectrophotometer, which works on the Beer-Lambert law. So the concentration of the analyte is correlated with an OD. So the same way the color is it is a color sensor, and the color. So sometimes if the color is low, it may not be possible to read it with the naked eye. So that enables the Arduino device basically enables high sensitivity, and sometimes the numbers might be important. So it's a color sensor in the Arduino device. So the red color appears in the kind of test what we have developed the technology in tech, but those tests are not available to the common people. Like there is a gap between the development of the technology and availability to the common people. So right now what is available is some kits are available. You can actually go to the Amazon, and it's possible, but they are very expensive. They're coming from the Western world, but they are taking also a lot of time, 48 hours like that.
So I believe Dr. Bhalla has answered.
Some other.
We cannot see. Should be here. So it's okay. He is the next speaker. Okay, Gaurav. So okay. Yeah. Yeah. Thank you, Dr. Okay. I like to thank Dr. Bhalla for his extended informative talk on biosensors. He discussed how the transducers produce electrical signals when biomolecules are detected. He also discussed the material coatings used in biosensors and how why we need to go to the nano size and how the gap plus width rule can be used. He also discussed how to measure antibody antigen binding if the current is not there, and how to use a mobile and touch screen. And also finally, how a mobile app can be integrated with a kit to have a point of care solution for detecting water contamination or explosive detection, so or the cardiac biomarkers. Thank you, Dr. Bhalla, for that informative talk. Before moving to our next talk with Dr. Mr. Gaurav Sharma, I request all the attendees to please, switch on their cameras so that we can have a group photo quickly, and that we'll be posting that photograph on our social media or here in the chat, so you can have the, memories for lifetime. Yeah, please switch on your cameras fast so that we can have a group photograph. Yeah, thank you very much. We can see some colorful faces playing Holi in the school. That's great. Yeah. I request all to switch on their camera. Yes, thank you. We can see teachers around sitting and having taking lectures. Yeah, thank you very much. May I request my teammate Sandeep or Vishal may please click a snap of this, and that will be shared on in the chat. So this will be our group photo, and we'll be sharing in the chat. Yeah. Okay, who can help? Vishal or Mohit can help in the group photograph. So thank you all. So now we can all switch off our camera so that next speaker can take on the stage, and we'll having last. This will be a hands-on session. Mr. Gaurav will be taking you to how to use cloud and cloud services, the available clouds facilities that you can use for your migrating your sensor data to the clouds, and how IoT can be used for vital sign monitoring. I believe we are running short of time, so please switch off your cameras. I am handing over the stage to Mr. Gaurav. Gaurav Sharma is the director of SSRB Private Limited, and he is delivering services in the domain of IoT, surveillance, healthcare, and many more. So without taking much of your time, Dr. Gaurav, Mr. Gaurav, please, over to you for your talk.
Hello, thank you so much, sir. Am I audible?
Yes, you are audible. We can also see your visuals. So you please share your slides if are there any. Or...
Sure, sir, sure. Just give me a moment. I'm just connecting my. So my screen is visible to all or not?
I believe it's coming through. Yes, yes. We can see a Word document.
Okay.
So I believe, Gaurav, you can straight away jump to the hands-on part, because we already have talked about the theoretical part in last 2.5 days.
Sure.
Yes, yes.
Yes. I had already visualized the timetable. So good morning. Welcome to the session. And today my topic is to basically create a account, or you can say that develop your cloud for your IoT data. So you can get the or acquire the data from the sensors, and you can just upload the on the clouds, different clouds. Basically, different clouds are available, like Amazon Web Services are there, cloudmqtt.com is there. So like Link is there. So these are the different clouds basically, which are available for freeware also, and they have their premium also. So you can get the as per your requirement. We will talk about the step-by-step procedure. So how to create account for the cloud. There are 3 clouds available. Basic applications you can perform on them. So I will not go for maximum theory part. I will give you some practical and step-by-step procedures basically. So how to start with the clouds? So if we start with the cloud, there is a cloud thingspeak.com. So here, these are the basic steps to setting up the cloud. So I chose the thingspeak.com, but
Gaurav,
as I say, there are the many.
Sorry, Gaurav, I'm interrupting you, but we cannot
Yes,
see your Word file or things, scrolling. Yes. I can see the IoT heading, the heading of IoT and IoT common application.
Maybe it is due to yeah, maybe it's due to network.
Yeah, I got it.
So just give me 2.
Yeah, it's visible. Somebody is saying is visible. Okay.
Okay. As you can see here, this is the ThinkSpeak basic steps to create an account. So as I have to start with it. So firstly, we need an account. So how we can create the account? So we have to go to the so as it will open. You can see here, there is an option for the getting started for free. On that.
Gaurav, we believe there is some connectivity issue. We have lost your audio and video. I'm allowing mic to Swarnalatha, teacher. If you have some query, in the meanwhile, Gaurav will rejoin. Swarnalatha, you can switch on. You can unmute yourself.
Okay. So
Gaurav, we lost your audio and video as well.
okay. Now am I audible, sir?
You're audible, but we cannot see your video. Also, we lost your video when you were showing, the login screen.
Yes, sir. Just give me a moment. There is an issue with lightning system here. So
Okay.
I just show you my screen share on my phone. So I will share the steps basically firstly. So after this problem will solve it, I will move to my PC. Okay.
Okay.
Okay. Okay. Just I'm sharing my screen. Okay. So my phone screen is visible.
It's visible.
Okay. Sure. So we will go to the ThinkSpeak. So it is open now. So as I'm logged in to another account, so what I will do, I will just log out. So now there is an option for create a new one. So we will go there. So it will show an error that this browser does not allow the third-party cookies. So what solution you have calculated with it? So what we have to do, we have to go to the mathwork.com. So basically mathwork.com company which develop the MATLAB software also. So ThinkSpeak is the another product developed by the MathWorks. So we will just make our account on mathworks.com. So what we have to do, first we have to put our email address here. So I'll take any email address like test IoT automation. So it will ask about the location and some another points. So you have to choose. So are you at least 13 years older? Yes. So we have to go to the create. So after that, it will tell you that check your email address. So we will go to our email address, verify our account. So you can see here there is a mail come from the mathwork.com site. So we will just verify our account. So here we have to put some points as they have asked to fill up. So name, password, like password, I will put the password. So like this, we just have to fulfill all the requirements for creating the MathWorks account. So it will ask for the activation key, but we have to we don't have to fill it because we don't have the activation key. We are going for the free trials. So we have to click on I accept and create. So as you can see that, so there is a profile is created in our MathWorks account. So basically, if it is created MathWorks account, so now what we have to do, we just have to go to the move back to the ThinkSpeak. So as my screen is visible. Hello. So after creating the account in mathwork.com, so just we have to go to the thingspeak.com and put our email address here, like test IoT automation, what we have entered in the MathWork. So click on next, and after that we have to write our password. So now we are logging into the ThinkSpeak site. So what we have to do next? We have to create our channel here. So what do you mean by channel? Basically, yes, sir.
Sir, so there is
Yes,
some
sir.
delay from your side. From I think your internet connection
Okay.
is weak. So could you change your place or find any space where you get the
Yeah, sure, sure.
network?
Okay, okay. I'm trying, sir. Okay, just wait.
Thank you, sir.
Okay, so is my screen is visible or not? Now, for now.
Yes, sir. Your screen is visible.
Okay. So if you now we are logging to the ThinkSpeak site. So firstly, what was the first step? Firstly, we create an account in Mqtt.com because Mqtt is the software development company which creates the ThinkSpeak cloud. So as we into the ThinkSpeak.com, the next step is go to the channels. So what is channel basically? It's like a page for you where you can display your acquired data. So we have to create a channel. We have to choose how many sensors data will displayed on this channel. So in free tier, it gives us only 8 channel, 8 basically the 8 channels to view to show the sensor data in one time. So there is an option for the new channel. As you go for the new channel, give a name to this channel like test IoT. So you can give some description also. So the next thing is fields. So what are the fields basically? Fields means how many sensor data can be viewed or showed in the in one channel. There are field 1 to field 8. So there are 8 fields available in free tiers. So you can show 8 sensors data in this. So if you want to show only data of 2 sensors, so we just have to click on 2 field labels and give a name to this field. Like first field will go for the temperature and second field will go for the humidity. Okay. So next thing is metadata. It is optional to fill it. So if you don't need to put some metadata or tags, you just have to skip this. Okay. After that, click on show status and save channel. So these are the simple steps to create a ThinkSpeak cloud account for the ThinkSpeak cloud. So as you can see that after creating the channel, we have 2 graph plots available on our channel. So with the name of temperature and humidity, you can see here. So we can just shift them as per our requirement. So now what we have to proceed for. So there are 2 views. First is the private view. Second is the public view. So in the settings, channel settings, you can see here, there is an option for private and public. Okay, public view. Okay, I'll just show you the in next steps that how to change the public and private view. So private view is for the only for the owner who have access to this channel, and public view is for all the people where you can share this link for this ThinkSpeak channel. If you share this link to the any of your users or clients, they can access the data visualization if this channel is have the public view enable. So if it is in private view, you or only owner can view this, and if it is in public view, everyone can see the sensor details. So after that, the next important step is API keys. So in the IoT domain, the API has a keen role. Why? Because API stands for the application program interface. It means if we want to interface our hardware to any application, we need these keys like a code. So why these are required? API keys help to secure our data. So as you can see that anyone can create a Mathwork account, and anyone can create the channel in the ThinkSpeak, but what data is sent to where means if you have a temperature and humidity data and you want to send it on channel 1, so it should go to the channel 1. So if it is going to the channel 2 or 3, it means the data is leaking. So to tackle that problem, the API keys plays an important role for that. So every channel has their unique API key. As you can see here, there is a write API key and there is a read API keys. So 2 API keys available for this channel. So what is write API key? Basically, if you want to send the data from hardware to the ThinkSpeak cloud or your channel, so you have to use the write API key. But on the other hand, if you want to acquire data, the stored data in the ThinkSpeak channel, so you need or require the read API key. So these both different API keys for used for the different purposes. So what we have to do, we just have to select our API key and use it in our code. So this is the third step basically. So in another step, there is a data import and export option. So in data import and export option, we can export or import data to our ThinkSpeak channel. What it means? It means if a data means a couple of number of data stored in your ThinkSpeak channel, and you want that data in a proper organized form in your PC from anywhere in India or out of even worldwide. So what we have to do, we just have to go to the export option and choose our time zone. As we know, our GMT is plus 5:30. So in plus 5:30, there are 3 time zones available, like Chennai, Kolkata, Mumbai, New Delhi. So you can choose nearby time domain, like New Delhi are nearby. So if we select our time zone, after that, if you click on download, it will download the Excel sheet of acquired data in your ThinkSpeak channel. So this is the simplest method to acquire data from anywhere. Suppose if you made a hardware, it is in the Chandigarh, and you want to get the data in Chennai, so you can follow these steps. So these are the basic use and steps to create a ThinkSpeak account. So now next step is come to the coding part and setting up the hardware for that. As you see, this is the Node MCU. Anyone? Anyone? Is it visible to you all? Okay. So this is the Node MCU, basically any of the internet or Wi-Fi enabled device can be used to send the data from sensor to the you can say that any of the clouds. So this Nodemc is a device which have a controller and a Wi-Fi chip inside. So this is the basically SoC system, single on chip system. You can see that system on chip. So there is only a single chip which have both the controller and the Wi-Fi chip. So basically what it do for us. So if you can see that there are some D0 to D7 or D8 pins, like digital pins are available. Here you can see there is a single analog channel available also. So you can use these digital and analog input output to acquire the data from the analog or digital type of sensors. So after that, we will move to the coding part or setting up this hardware. Just give me 2 minutes because the problem is solved and my PC is restarting. So because as per your timetable, you are familiar to the Arduino Ide. So I will also work with the Arduino Ide to setting up this Nodemc hardware. And I'll tell you that how to make an connection with the any sensor, or how to send the sensor data from okay. So our first step to create an account for ThinkSpeak is done, and getting started with ThinkSpeak is also done, because I also show you the how to create a new channel for your ThinkSpeak account, and how to create the fields for that. Okay, like this, the same procedure I have used. So after that, I'll show you that how to initiate or setting up to our Nodemc to send the data from sensor to the ThinkSpeak cloud. So these are the basic steps, like how to configure the ESP8266. Why I use the ESP8266 word? Because in Nodemc, it is a combination of a microcontroller and ESP8266 Wi-Fi chip. So that's why it is mentioned ESP8266. So the first step, in previous days, we need to change the, you can say that the firmware. So by using this software, which is the Firmware Updater, so we update the firmware of Nodemc. But nowadays, if you purchase a new version of Nodemc, you don't need this step. But if you have a newer version, or if you have a older version of Nodemc, you can go with this step if you want. But for nowadays, if you get the new version of Nodemc, you can skip this step also to update the firmware version. So what is the firmware update? Basically, every digital IC which can perform the task related to the system configuration, like there is a Wi-Fi chip and Wi-Fi chip needs some settings, like if you have to add the SSID for that, password for that. So the another settings are like if you want to put some IP address to that Wi-Fi chip. So these are the system settings. So the devices which allows you to change the system settings, they need a firmware inside to perform that task. Okay, so this firmware is already updated in the newer versions, but in older version we change this by this firmware updater software. So you can skip for that for now. But the next step is to open the Arduino firstly. So I'm just opening the Arduino Ide. So after the flashing the firmware into the Nodemc, we have to go to the Arduino Ide. And if you skip that step, then it is okay. We can move to the Arduino Ide, and what we have to go, firstly, we have to go to the file and the preferences option. Is it visible clearly, or I have to zoom it for you? So in file, this is the preferences. So by clicking on this, a dialog box will appear. Okay, so here you can see I put a JSON file. Okay, so what is this JSON file? It is for the STM32 microcontroller. So same this JSON file, we need the JSON file for the Nodemc or ESP8266 Wi-Fi boards. So how we will get in our PPT? I just have this JSON file. Here you can see the steps how to make Arduino compatible for programming ESP8266. So here you can see the dialog box for the preferences, and there is the JSON file here. This is the JSON file for the ESP8266. So I just copy it and place it here. Okay, and press OK. After adding the JSON file for the Nodemc, click OK and go to the Tool and Boards Manager. Here you can see the Boards Manager. So after this dialog box will appear, and it will download some platform index file. So wait for the completion. After that, we have to type here ESP8266. Because so why we need this step? The main question arises that why we need this step. Because Arduino Ide was firstly developed for the Arduino development board only, but because it can code the other type of development boards like STM32, ESP8266. So what we need to add the board files for them, because Arduino Ide have the board files for Arduino development boards, but it doesn't have the ESP8266 board file or STM32 board file in by default. So we have to add them. So that's why we need this step to add the board for ESP8266. So after writing the ESP8266 in the search bar, you will get this. And here you can see, you can select the version. So updated version is 3.0.2. So I'll just select it and install it. So it will take some time to download the board files, and after that installing them. So just 5 to 10 minutes, if even less than 5 minutes, if the network is good. So while it is installing, we just go watch the other steps to configure after that. So what we have to do next, we have to write this AT command. See, there are two methods to code or change the system setting of any electronic device. If it allows the AT commands, so we can use the AT commands to change the system settings, or else there should be a software which can change the particular electronic device's system setting. So there are two options to change the system settings. First are the AT commands, and another is the should be any software available for that. Okay, so what are the AT commands? Basically, AT commands are the attention commands. These are the you can see that you can say in the layman language, they are the machine codes for that, for the any electronic device. So by applying these AT commands, we can directly change the system setting without using any software. So how to put that AT commands into a hardware? So it can be sent by any of the communication protocol, like serial communication protocol, like UART, I2C, or SV communication. If any of the serial communication is available in your electronic device, so we can send these AT commands to that device to change the system settings. So as you can see, it is installed, and after this you can see before in board manager only Arduino and STM32 board options was enabled, but after adding the ESP8266, we have now the ESP8266 board option available in the board manager. So what we have to do, we just have to choose the Nodemc 1.0 option here. So these are the basic steps to configure the Nodemc. So now what we have to do, we have to initializing it with AT commands. So what are these AT commands and how does they work? So I'll just give you the detailed view about that. Like AT stands for the attention. The first command sent to the Nodemc for attention that we are going to send you the AT command. So this is the first command we sent before sending any of the AT commands like AT plus RST, AT plus GMR. So firstly we send the AT to attention the Nodemc or any hardware that we are going to send you the AT command. After that, we reset the hardware by pushing the AT plus RST command. AT plus RST command stands for the resetting the hardware by AT using AT commands. Okay, so the next is the AT plus GMR. So this AT command used to know the model number of the Wi-Fi chip used in the Nodemc. So it is to know the model number, or you can say that the firmware version also of Nodemc. So next command, AT plus CW mode equals to 3. This command is used to make our Nodemc as both like station and the transmitter. Means our Nodemc can transmit and receive the data at the same time. Okay, so for that purpose we set our Nodemc in this mode. So this is to change the mode of the Nodemc. Means we have 3 modes, like only if you want to just transmit the data from Nodemc, you just have to put here 1. If you want to receive the receive the data from the any cloud to the Nodemc, you have to put 2 here, and for if you put 3, it will set to the mode for both transmitter and receiver. So this is for the setting up the mode. transmitter and receiver. Okay, so our node MCU can receive the data and transmit the data same time. So the next AT command, you can skip this AT plus CWLab, this command, you can skip this. You can directly come to the AT plus CWLab command. So what is used for this command? Suppose there are some internet connections available, like Wi-Fi connections are available. Like I turn on my mobile hotspot. So my hotspot name is like CSIR Chandigarh. So if I put this AT plus CWLab command to the node MCU, so it will give me the list of the Wi-Fi connections available nearby me. So this command is to show the Wi-Fi or internet connection available near me. And after the after this AT plus CWLab command, what we have to do, we just have to watch the SSID and the password of that particular Wi-Fi connection to which you want to connect your node MCU. So if the SSID is the P7 plus and the password of that particular Wi-Fi connection is this, so we have to use the AT plus CWJP equals to in first invited two inverted commas you have to write the SSID, and in second inverted commas you have to write the password. So in this method we are connecting our node MCU to that particular Wi-Fi connection, so by applying this AT command. So as you can see, there are 4 to 5 AT commands by which you can just connect your node MCU to a internet or to a Wi-Fi connection. These are basically 4 to 5 commands, AT commands. So how to put that AT command? Nothing to do with it. Just go to the tools, choose your COM port. Okay. So how to choose the COM port? If you connect your if you will connect your node MCU to the PC, so there will be a COM port. COM port is the communication port. Like there will be a COM4, COM6, any one of them. So if you connect any of your node MCU device, so select the COM port and go to the serial modem. So because it is not connecting yet, so it is not opening. But if your device is connected and you choose the right COM port, so serial monitor will be open and you can send this command. And one setting. So after setting up this command, we have to move to the coding part. So what is the coding part for the ThinkSpeak Cloud? Firstly, I will show you the circuit diagram. So as you all can see this circuit diagram for the DST11 sensor, this is the temperature and humidity sensor. So what are the connections? The ground is connecting to the ground, BCC is connecting to the beam, or you can also connect to the 5 volts where it is available. So the next thing is there is a data output pin. The second pin is the data output pin, and we have to connect it on the any of the digital pins. Like there is D4, D2, D1, D0 is available. But if I connected it to the D3, it doesn't mean if it cannot be connected to the any other pin. It can connect to the any pin of the node MCU, any digital pin of the node MCU. So you can change according to your requirement. But if it is connected to the D3, it means in our code, I will use D3 GPIO pin for the data of the DST11 sensor. So now we will come to the coding part. I'm just showing you the firstly simple code for that. Let me take this code. So coming to this point, the two libraries are added for the initializing the or initializing the setting for the ESP8266 and DST11 sensor. Why we add these libraries? So as you can see that first library is the DST.h. DST stands for the digital humidity temperature sensor. So because in our diagram we use the DST11 sensor, so for that particular sensor the library is available for that. So we just include that library, and the next library is the ESP8266 Wi-Fi.h. So this library is added for the basic use the basic functionalities of ESP8266 Wi-Fi chip, means Nodemc. If you want to use the basic functionality of Nodemc in your code, so you have to add this library. So why I'm talking about this library? So there may be a question in your mind that why ESP8266 Wi-Fi.h? There should be available any library with the name of Nodemc. So I told you that Nodemc is a combination of a microcontroller and a ESP8266 Wi-Fi chip. So we have to use the basic functionality of a Wi-Fi chip of the Nodemc. So that's why it is available with the name of ESP8266 Wi-Fi.h, not with the name of Nodemc. So after adding these two libraries in our code, the next step is to add the API key for ThingSpeak. Here you can see that. So what we have to write there, the API key, like the API key was, I have to log in it in my computer also, like IoT automation. So I will open my test IoT channel because we had created it before, and in API key option, our API key will be available here. So I'll just open the API keys option, and you can see here write API key. So I just have to select this API key and copy it and paste it here between the inverted commas. Okay. So these are the first step to add the API key. After that, there is the SSID. So which network you are connecting to the Nodemc, means if your Nodemc is connecting to a network, so you have to add the SSID and password for that network. Like Gaurav is my SSID for the mobile hotspot. So I'll add here. I'll write Gaurav 5. So this is my SSID, and if I want to add the password for that, so I'll add the password. Okay. So this is my SSID and password. So we just have to add this in our code. So what is next? Next is the link, or you can see that the IP of that cloud, means every website has their own IP address. So if you can see here, to send the data to the to your channel, there is the link is with the name of api.thingspeak.com. So it is common to the all ThingSpeak channels. But what will be the difference? There will be the difference of API key. So link means everyone every person who is using the ThinkSpeak will hit this link to send the data, but the change of API key will decide that which data will go to the which channel. Okay, so after that, okay, now the next is we define the DHT pin is 0. So as you can see there, in the diagram we use D3. Okay, but we use DHT pin 0. Okay, so why it is different? Because there are two types of pins available, right? First is the digital pins with the name of D4, D3, D2, D1 and D0, and another is the name of GPIO 0. If I show you the detail pin out of Nodemc, okay, so if I show you the detail of the Nodemc, you can see here we can choose any of the nomenclature. Like if we want to go with the D0, D1, D2, D3, we will write the D0, D1, D2, D3 in our code. But if you want to go with the other type of nomenclature like GPIO, so you have to choose the GPIO 0 for D3. Here you can see GPIO 0 for D3. If you use D2 to interface the DSC sensor, so you have to choose the GPIO 4. So like this, you have to select your GPIO nomenclature. So there is the GPIO 0 for D3, where our sensor is connected. So that's why we use 0 here. So what are the hash defined here? Basically, this is the these are macros. Why they are defined like this? So as you can see that there are only 83 line of codes. Okay, so if there is a code of 2000 or 3000 lines, so and we use this DSC pin 0 in this code for like 150 and 250 times. So if we change our pin for the sensor, so we have to change the DSC pin 0, DSC pin 0 for 150 or 250 times in all over the code. So it will take more time to edit it. But if we use macros here, so as we will we are saying that there is a DSC pin which are representing 0. Okay, so in all of the places where the DSC pin will use, if I change here 0 to 1, in every place of DSC pin, it will be assigned to the 1. So you don't have to edit or change the value of DSC pin manually. You can just change here and it will change the value in all over the code. Okay, for DSC pin. So that's why we use macros here. So after that, there is a function DSC where we are using the DSC pin and type of sensor. Basically, this is the pin of sensor and another is the type of sensor. So there are so many type of DSC sensors are available, like DST11, DST22, DST33. So like this, there are many types of DST sensors are available. So we are interfacing DST11 type of sensor. That's why we type here the DST11 sensor. If you are using DST22, so you will write the DST22 type. Okay. So why it is required? Because DST11 and DST22 sensor, they are working on the single line data communication. So they have their own addresses for that. So DST11 has the different address. So DST22 has the different address. So that's why we have to choose it respectively. And DST pin defines the 0. If you don't want to write the DST pin here, you can write directly 0 here. So it will describe that GPIO 0 is connected to the DST sensor, and that DST sensor is the DST 11 type sensor. So this line means that. So I'll put the DST pin here again. So what are the next? So next is the void setup and void loop. So as you studied the Arduino Ide before, so there are basic two functions are available. First is the void setup, where we write the code which will run only once, means it can run only once at the time of initialization, at the time of start. So it will not run for repeatedly in the whole code. So but the things right in the void loop will run repeatedly, means our compiler will run and read this lines of code repeatedly. So by the lines written in the void setup, it means we just have to initialize these settings, and we want that these lines should be initialized only once. So what we have initialized, firstly we initialize the serial.begin, means the serial communication should be start with the baud rate of this 115200. Okay, so with this baud rate our serial communication should begin. So there are different type of different values of you can say the baud rates are available. So as per your requirement, what speed of data transmission you required, you can change your baud rate here. Like there is a 115200, you can go with the 9600 baud rate also. You can go with the 4200 or 4800 baud rate also. So it depends on your requirement that what data speed you need. Okay. So the next thing is serial print connecting to. So we are just printing this connecting to character on our printing screen, and our SSID and password also. Okay. So these commands, this command basically Wi-Fi.begin with SSID and password. This command will help to Nodemc to connect with my SSID and password, so that it can connect to my hotspot, or it can connect to my internet connection basically. So this line express that. After that, we are checking the status of connection, means after pushing my SSID and password to the Nodemc, is it connected or not? So after that, our compiler will go to this loop and check the status. If my Nodemc will connect, so it will comes outside and tells you that Wi-Fi is connected. Okay, or else it will show you the connection error. Okay, so after initializing, we will come to the looping part. Looping part means the process we want to run repeatedly in our code. So what we want that it should run repeatedly in our code. First is the dst.read humidity and dst.read temperature. We want that our Nodemc should read the humidity and temperature from the DST sensor repeatedly, means again and again. Okay, so that we can get the updated value from the DST11. So after writing this, we write a if condition that if there is any error in while reading the humidity and temperature values, so it will show the fail to read the DST sensor. If there is any there is no problem in reading the humidity and temperature, so it will go to the next if condition. So next if condition is the that server that our Nodemc will connect to this port. Why this port is required? As you can see that port is the basically the starting point where it will hit the or where it will hit the link of the ThingSpeak cloud. So we need a port for that. the port of the server is 80. So it is the basically mostly used port. We mostly use the 80 as a port name for any server. So these are the basic initializations to hit that link. So after that, what we are doing, we are just assigning the API key to the post string variable. This is the variable. So we are just assigning the API key value in this. So what is it in the API key? Let's see. It is our API key, this. So we are just assigning this characters, group of characters in the post string variable. Okay. So we will use this post string variable in further. So that's why we put the API key in this post string. So after that, what we are doing, we are just telling the Nodemc that in field 1, we will show the temperature data, because T stands for the temperature data. Here you can see T. Whatever the readed value from the DST sensor for temperature is stored to the T variable. So we will send or visualize the temperature data in the field 1. What is the field 1? Field 1 is this. This is the field 1 chart for temperature. Okay, that's why we are telling our Nodemc that temperature data will go to the field 1 and humidity data go to the field 2. Okay, post string. And after that, what we do? So we just write the HTTP. After that, api.thingspeak.com, that is the link where we want to hit our data. And the next is the API key. We send the API key with that so that it can differentiate or secure our data. And after that, we tell the connection type. Okay. And the length of the content, basically, and post string length means post string. This is the API key for our. So by applying these steps, we send this data to the ThinkSpeak cloud in this format. Okay, and what is this format? This format is known as the JSON format, basically. And after that, if you want to skip these lines, you can skip that, because it will show you the temperature data and humidity data on the serial print screen, which is there, serial monitor. So if you want to skip that, you can skip. And after that, client.stop. So by this code, you can send the DST data from Nodemc to the cloud. So this is the basic code for that. Now I know that for the freshers or for the beginners, it is not easy to understand, or it is not easy to remember the process also. So what we do, I'll just share you the Word file for which I write or which I made for this step-to-step method. So I'll share you, but it is all about the practice. What practice we will make for this ThinkSpeak cloud method. So I'll just show you that how we can visualize the data on ThinkSpeak, because we made automatic weather station where we use different weather sensors like ambient temperature, humidity, barometric pressure, soil temperature, soil humidity, the different parameters of the weather. We acquire them and we send them to the ThinkSpeak cloud, and to store that data in our ThinkSpeak cloud, so that our client can access that data from anywhere. Okay. So I'll just show you how it visualizes in ThinkSpeak. So I'll just sign out and show you our client data. Just wait for a while. So here you can see we made 2 channels for our client. Okay, so in channel 1, so you can see created 2 months ago and last entry is 2 minutes ago, means it is the live data which I am just showing to you. Okay, so this is the visualization of the data in the field chart. You can see that the wind direction sensor, wind speed sensor. So by clicking on these nodes, you can get the sensor values like wind speed ms equals to 3, it means 3 millisecond meter per second. Okay, so the wind speed is the 3 meter per second, and the date of the data collected and the, you can say, the time also. Okay, so this is the live data monitoring, you can see here like this. So these are the all data values like rain. So it is showing that there was rain today, and it was about 10 mm per hour. So these are the values available. This is the solar radiation. You can see here the different values on different time spans. This is the data of today's basically at various time domains. So you can download this data if you want to analyze it properly. So what we do, we just go to the data import and export. We will go to the export option and choose our time zone. So here New Delhi, and I will download this data. It will be in CSV format. So it is downloaded. So this is the feed.csv. So you can see in this Excel sheet, it is showing you the date, time, and the data in the different fields. You can see here. So we can download this by going to the export option. So you can see that this data is from 30 December 2021 to till date. Look, you can see that at the last, it is 16/3, means 16 of March 2022. So there is a lot of data you can acquire. So this is the practical live application basically. So in today's session, I just discussed the step-to-step method to create an account to make an account in any cloud, and if the setting up method for hardware, that how to set up a hardware for sending that data to the cloud, and the code for that also. So anyone have any questions regarding this?
Yeah, hi, Gaurav.
Yes, sir.
I could read a few questions in the chat.
Sure.
Hereby they are asking whether this data can be sent on a particular phone number as an SMS service, or and another question
Yes,
is
sir.
how, yeah, which sensor are you using for solar radiation?
Okay. So first, the first question was that can we get the data on mobile phones? Or so definitely we can get the data on our mobile phone through SMS, but there is an issue. The first issue is in a single day we can't go above the 100 SMS per day. So we can just send the 100 SMS in a day. So it means you can get the only 100 sample of data in a single day. Okay. And other thing is that you need a different module for that. That is the GSM module. So this Wi-Fi module will not help you to get that data in your mobile phone through an SMS. So what we have to do, we have to use the GSM module for that. So we will have to put the SIM also in that GSM module, and that SIM will send the data, the acquired data from the data logger to your cell phone. And the second answer is the which sensor we use. There are so many industrial sensors are available in the market. So what is the sensor basically model of that sensor? I'll just show you. So there is this type of data logger we use. Okay, so we can see or observe the sensor data on this LCD screen also. Okay, so there is a keypad is available on it to change the sample rate. As I tell you that it can be from 1 minute to 2 hours. Okay, so it means you can set it to the 1 minute for the lowest. It means the sample will uploaded or updated after 1 minute. Okay, and if you set it to the 2 hours, it means the sample will update after the time of 2 hours. So this is our data logger. These are the different industrial sensors like temperature and humidity sensor. You can see here, because there is a effect of environmental. So there the shield is used for that particular causes, because this shield is the ultraviolet protected shield for our sensor, and it helps to keep safe our sensors. So these type of industrial sensor we use. So there is this is the PIRA 300V, the solar radiation sensor. So this sensor we have used in our weather station, PIRA 300V.
Okay.
The other sensors.
Yes.
Yes,
I believe you answered that question, Gaurav.
Yes.
There's another question. How
Yes,
did you measure the moisture, and what approach did you adopted to calibrate the moisture sensor or the other sensors? Or
Okay.
were they
So
calibrated?
yes, sir. Yes, sir. Sure. Okay, so as you know that there are different type of sensors. Different types means not about the sensor type. Basically, it is the data output which comes from the sensor. So our sensor can be a digital sensor, analog sensor, or there is another type of sensor are communication based sensors. So if you are using any analog sensor or digital sensor, then you need a calibration you formula for that to make that values to understandable values. Okay, so the calibration factors are only considered for the digital and analog sensors, but for the communication sensor types, like some of the sensors give us data which are pre-calibrated. It gives us data on the SPI protocol on the behalf of UART protocol, I2C protocol. So we use that protocols to retrieve the data from the sensors, so which is pre-calibrated. Okay, so why we use pre-calibrated data? No, even we are not using all the sensors which are pre-calibrated, but some of the sensors are pre-calibrated in our weather station. Okay, but the basic use of pre-calibrated data is you don't have to focus on calibration part. This is the one point, but the accuracy of that sensor is also matters. So it may happen that if you calibrate an analog sensor, which is a temperature sensor, and you calibrate it, but it may happen that it not be an accurate. Okay, so due to accuracy, we choose the communication-based sensors, but most of the time we also use analog sensors. Like this wind speed sensor is a digital sensor which gives us the pulse output. Okay, now in this data sheet, you can see, I'll just tell you how to calibrate it, the basic fundamentals. Just zoom it. Okay, so in this sensor, you can see here, this is the wind speed sensor. Now it tells us the range. The range is between 0 to 250 kilometers per hour speed. Okay, and the accuracy is the plus minus 3%, and the output is the 62 hertz equals to 250 kilometer per hour. It means if I put the DSO, digital signal oscillator, at the output terminal of the sensor, so if there will be a pulse output. Okay, so if it is 62 hertz pulse output, so it means it is rotating with the speed of 250 kilometer per hour. Okay, and if it is not rotating, so it will show the 0. So it means at the 0 hertz there is a 0 kilometer per hour. So by using this values, I will make a calibration formula. Okay, that how much speed will be there on 60 hertz, on 20 hertz. Okay, so we have to drive that formula for that. Okay, so basically we use the this is the sensor which are giving the specification also. So it means you know that what is the range of that, or what is the maximum range. Okay, but some of the sensors you don't have the range. So what you have to do with that type of sensor? So if there is a sensor like temperature sensor, okay, there is a RTD. So what you have to do, you just have to place that RTD in a you can say that water, okay, a jug of water, and you have to take another calibrated meter, temperature meter. You have to put it to the jug of water also, and you have to heat that water. Okay, so the temperature of the pre-calibrated meter will change, like it is changing from 10 degrees to 15 degrees, and your sensor giving you value from 200 to 300. So you just have to note down that values. Okay, so you have to take the 3 or 4 updated values, and after that you have to put it into the linear equation. Okay, so I'll just show you that how linear equation helps us to calibrate.
Gaurav, I believe we
Yes,
can cut it short here. You talked really well about calibration and other things.
Okay.
I believe we can leave it to the participant to search for the linear equation and other things.
Sure.
Yes. So because we are running a bit late, so yeah.
Sure.
Yeah.
No problem, sir.
So before I thank you, I request you if you can share the Word file which you use for showing the
Yes,
things
sure, sir.
integration in the chat box, so that
Sure, sure, sir.
yes, all can be benefited.
Okay, just give me a couple of minutes. So I'll share you the steps to configure the ESP8266 file, and the another file is this.
Everyone to please shoot emails to Gaurav on his email, and I would believe that Gaurav would be generous to leave his email in the chat box so that you can shoot all the questions to him on email or
Sure, sir.
the phone calls if he provides his number.
Sure, sir.
So yeah.
Yes, sir.
So
So you can share my number also. There is not an issue with that.
we will. I request Mohit to share
Yes,
your
sir.
number in chat box and as well the email as well. Okay, with
Sure,
that,
sir, sure.
let me take this opportunity to thank Gaurav for talking at length about creating accounts on ThinkSpeak Cloud and how to use ESP8266 microcontroller with Arduino, and how you shown how we can use 80 commands to check ESP8266 board connected with Arduino Ide working or not, and also 80 commands to connect ESP8266 with Wi-Fi internet. We also discuss DHT libraries, ESP8266 Wi-Fi library, and how to use the APIs for reading and writing the key, and how to send the data to the cloud for analytics and or the future usage. Yeah, and finally you showcase a case study where you shown data from real fields for the analytics or the other purposes, and you answered the question really well. Thank you, Gaurav. With that, we are reaching to the concluding session of this workshop. But before we wrap up, I would ask my colleague to please share the quiz link in the chat so that the attendees can participate in the quiz and win some prizes. So Mohit and Vishal may please put the quiz link in the chat, if not as of now. And since we had some queries about the winners of the last 2 days quiz, I'm sharing the PPT slide for the sake of all knowledge of all. So here we goes. So these are the winners of day 1 quiz. Mr. Praveen Kumar Verma from Kendriya Vidyalaya Ordnance Factory, Katni, Madhya Pradesh. Second spot, Mr. Sandeep Kondal, Government Senior Secondary School, Mohal, Himachal Pradesh. Shivam Raghuvanshi, Kendriya Vidyalaya, Chanakpuri, New Delhi. Day 2, we had our winner as Sumit from RKP Senior Secondary School, Madina, Rohtak, Haryana. Vinod Kumar from Jawahar Navodaya Vidyalaya, Bastar, Jagdalpur, Chhattisgarh. Shankar Prasad from Kendriya Vidyalaya, Ramakrishnapuram, Sector 8, New Delhi. So these are the winner for last 2 days. We'll be sharing the quiz today and we'll update on our social media and through email as well. And I request all participants to stay patient for 1 week to receive your certificates, because it will take time for us to analyze your attendance records, and because since we mandated 100% attendance on all 3 days for your receiving certificate. So we'll be checking your attendance and we'll get back to you with your certificates, those who attended the workshop on all 3 days. With that, I would like to convey my thanks to Dr. Sanjeev Khosla, Director CSIR-IMTECH, for guiding us and motivating us for having these sessions. Dr. G.N. Shastri, who is the Chairman of Task Force Committee Jigyasa. Dr. Geeta Vani Raisam, Head HRDG CSIR. Mr. K. Sridhar, Coordinator CSIR Jigyasa. Thanks to CSIR for supporting this program. Thanks to all speakers from day 1 to day 3. Our dignitaries, the guest, Ms. Dupali Upadhyay from Niti Aayog, Dr. Biswajit Shah from CBSE, Dr. Kota Solomon Raju from CSIR-NAL Bangalore, Dr. Ninath from KJ Somaiya College, Mumbai, Dr. Sanjay Singh from Siri Pilani, Dr. Ninath again from KJ Somaiya College, Mr. Baljit Singh from CSIR-CSIO, Chandigarh, Mr. Gaurav Sharma from SSRB Private Limited, Punjab, Dr. V. Bhalla from CSIR-IMTECH, and my team, Vishal, Mohit, Sandeep, and Mohit Singhal again for supporting the program. And I also thank to the administration and the regional officers at Kendriya Vidyalaya Sangathan and the Jawahar Navodaya Vidyalaya, state education departments, schools, principals and managements who could, make it possible, forwarding our invites to you people so that you could participate in the event. And thank you everyone who supported this program. Stay calm, no problem. We'll make it the link available for the attendance, marking attendance. Please participate in the quiz to win some prizes and the appreciation certificate. And yeah, last one request, I would like you to please fill the feedback form also so that we can get back to you with more programs. And you please let us know what kind of program you want to attend, and so that we can design some new program for you. With that, if anybody wants to say something, I can put you on microphone. If not, we can conclude this workshop here only. If anybody wants to say something, please raise your hand. I can give you mic for a few seconds and you can say a few words. Yeah, SP Singh, please use your mic to if you want to say something.
Audible, sir?
Yes, sir. Yes, sir. You are audible, sir.
Once again, thank you, sir, for this type of workshop, because I am attending it for the first time. And as I asked the question on, I think first day, yeah, or second day, sorry.
Second day.
Yeah. Okay. Because since it was my first situation and I was not in contact with the ADL situation in the schools, I belong to the training side, KBS training at ZIIT Chandigarh. So I was not having a clear picture of it. But now, since we are training the teachers and the way 3 days went, now at present, I can very well confidently say that a picture has been developed in my brain, how to take up these small points, because the whole workshop was on sensors, calibrations, and how these sensors can trigger. The students can be made to think on certain things and to use those instruments. The instruments are available in the market. And let us, what I was thinking was that this type of training can be a little bit triggered in our sessions also, just giving the teachers a little trigger. Okay, see, the material is there in the school. This way it could be used. Students could be triggered in this way. And if there are 200 students in 9th and 10th, suppose, and if 10 get triggered and they are given a chance to explain or demonstrate in front of others, I think there would be a chain reaction of triggering. This is what we are thinking now. And ATL and this workshop has provided us the word sensor. I cannot forget, because every time
Sir, we missed your voice for last like 10 seconds, I believe. I believe there's some network issue.
Sir, I was not audible.
Yeah, now you're audible, sir. We missed for like 20 seconds.
Okay. I was just saying within these 3 days earlier, I was not having a clear picture of it because I was not in contact with the ADL situations in the school. But now by third day, we are very clear because I am in the training side. So what makes me more clear is how to take up this particular issue during the trainings that we plan here for the teachers, and how this concept could be triggered to the students in the school. That concept as picture is clear to me, and I hope this will be taken up in the right way. Thanks for organizing this 3 days workshop. Thank you very much, sir.
Thank you very much, sir. Your words are really motivating for us. That our efforts now I believe are successful because we were able to convey a few concepts to the teachers. Thank you very much, sir, for that. With that, Parveen Kumar and followed by Mr. Pawan Kumar can say what down the word. Yes, Parveen and Pawan.
Yes, sir.
Yes.
Yes, sir. Pawan Kumar Patidar, sir.
Yes, please. Go
Am I
ahead.
audible, sir?
Yes, yes, sir.
Yes. Sir, I'm very grateful to CSIR for conducting these 3 days workshop. Really, it is very helpful for us. And now we are thinking that we can train our students also in a better way. Because earlier we were not able to understand the things and how to explain students, because we are the first one to whom students are going to contact how to use this and what for this thing is being used. Just one more request is there, sir. Whatever taught during these 3 days, it should not be stopped here. It should be continued. And the second one, the 3 days videos, if it is available, then later on also we can see all things and we can get. Thank you, sir.
Okay, sir. That being said, sir, what we'll do, we'll share all the resource material on the YouTube channel of CSIR Jigyasa. I will share that link with you all on the WhatsApp or the email. And other things, sir, let me tell you, we will be organizing a workshop in March only on data analytics through R programming. That would be really helpful for you. So I would request you to please keep checking our website of CSIR-IMTECH, that is imtech.res.in. I'm putting in chat so that you can also register for that workshop also. So this is imtech.res.in. Please register for that workshop also. Yeah, somebody wants to say something. Parveen Kumar ji, Manish Gupta ji.
Yes.
Yes, one by one, please. Okay, Parveen Kumar ji first. Or I believe Manish Gupta ji, yes.
Good afternoon. Good afternoon, everyone. So that was very fabulous and really we enjoyed it. And one more thing, like there are a lot of topics, as you know, in the Adult Thinking Lab for the students. Okay, so if you can start doing this type of workshops, because you know that students are coming and mainly they are asking for the 3D printing, because you know that all things are related to the 3D printing, because robotics and all they can they are searching in the YouTubes and doing all the things, but 3D printing is that topics in which we have to work. Okay, so I'm ATL-Incharge in Navy schools in Delhi. So I'm saying, like you said in the very first date, the very correct things key everything is in locked. Students and teachers, even they are not using. So maybe the first reason, the reason is that COVID. Okay, this pandemics, because online we are trying to do, but you know that students are very like fed up with the online things in this since 3 years. So we stopped sometimes, yes, it is true, But now we are open, and students are coming and they are making a project for the ATL marathons and various competitions inter schools and everywhere. So I'll request two things. First, just like as soon as possible, if you can do it, the workshops in the 3D printing, and the group is that WhatsApp group which you made. So keep it in the like running, so that whenever you will do any workshops or any widgets, if you'll offline, if you'll provide, so just you just inform in the group so that we all can know about it. That's really nice.
Okay. Thank you very
That's
much, Manishi. So we will keep those groups alive, but with a request that please don't spam. Though I would put a request in their group that please don't spam the group. Keep it meaningful for updates on some training or other things. And yes, please take patient for your certificate because it will take time and logistics to for us to decide who were there for all 3 days. So with that request, we'll keep the accounts, the WhatsApp group alive. So I believe if there are no more feedbacks, uh, uh, so please, everybody can give their feedbacks in the Google form that we shared, and also please fill in your attendance, and so that you can have those certificates. So thank you very much for joining for all 3 days, and stay glued to your screens and being enthusiastic, putting questions forward, attending quiz, everything. So yeah, we also loved your enthusiasm. Thank you. Thank you very much. Yeah, I'll be leaving this session here till the quiz is over.